All right, let's jump right in. Welcome to the Foundry by Forge College. I am absolutely thrilled to be your guide through today's explainer. Now, if you caught our previous explainer, Capstone Overview, Secure Wallet Goals, you know we laid down all the foundational theory of what we're actually trying to achieve with a secure wallet. But theory really only gets us so far, right? Today, we are taking that leap from abstract concept to concrete reality. We're going to walk through the exact step-by-step methods you need to generate seed phrases, evaluate all your backup options, and ultimately build a completely bulletproof offline recovery strategy. Let's get to it.
Okay, so here is our blueprint for today. First up, the ultimate master key. Then we'll be decoding entropy and mnemonics before tackling the backup balancing act. After that, we'll shift into building your disaster plan. And finally, we'll wrap up with rehearsal and next steps.
Starting off with Section 1, the ultimate master key, securing the HD wallets.
Now, to really wrap our heads around what we're protecting here, let's use a super simple, relatable analogy. I want you to imagine you own this massive, sprawling mansion filled with thousands of rooms, safes, and vaults. Now, a hierarchical deterministic wallet, or an HD wallet for short, is essentially a system where you don't need to carry around some ridiculously heavy keyring with thousands of individual keys. Instead, you have one single, powerful root secret. Think of it like a magical master key that flawlessly and reproducibly creates the keys to every single door in that entire mansion. So if you just protect this one master key, you've secured access to everything. It completely eliminates the total nightmare of trying to back up hundreds of individual keys every single time you use your wallet.
Moving right along to Section 2, decoding entropy and mnemonics, the science of randomness.
Okay, let's peel back the curtain a bit and look at the actual technical mechanics of how this master key is forged. It all starts with this fundamental concept called entropy. Entropy is basically just unpredictable, raw, random bits, like a chaotic stream of ones and zeros, sourced from a highly trustworthy generator. This pure randomness is the secret input for your seed. Think about it. If your entropy is weak or biased in any way, your master key could literally be guessed by a computer, which totally defeats the purpose. But here's the thing. We human beings are notoriously terrible at memorizing strings of raw binary code. So we use industry standards, like BIP-32, to take that raw entropy, add a clever little mathematical checksum to catch typos, and encode the whole thing into a mnemonic. A mnemonic is really just a human-readable list of words. That's the whole magic trick. Your seed phrase is simply raw, chaotic math, beautifully translated into a language you can actually read and write.
Now, what's really interesting here is the delicate trade-off we have to make between brute force resistance and plain old human error. You actually get a choice when it comes to the length of your mnemonic. A 12-word phrase gives you 128 bits of entropy. For most everyday use cases, that is incredibly strong. Plus, and this is absolutely crucial, writing down 12 words carries a much lower risk of you making a silly spelling mistake. On the flip side, if you jump all the way to 24 words, you get a massive 256 bits of entropy. That is near maximum practical resistance against a supercomputer trying to brute force your wallet. But the catch? You now have a significantly higher transcription burden. More words simply mean more chances to write something down incorrectly, which could render your entire backup completely useless. And then, of course, we have the infamous BIP-32 passphrase. This is an optional extra word or a whole phrase that you can slap right on top of your generated mnemonic. It's an incredible security booster, really, because an attacker would need both your written list of words and your secret passphrase just to crack into the mansion. However, and I really cannot stress this enough, you have to beware the single point of failure here. If you are the kind of person who constantly forgets your passwords, adding a passphrase might mean you successfully lock the thieves out, sure, but you also end up locking yourself out of your own mansion forever. No thanks.
All right, Section 3, the backup balancing act, surviving the elements.
So, we know exactly how the key is made, but how do we actually protect it out here in the physical realm? From floods or fires or, a really clumsy roommate? I want you to burn this golden rule right into your memory. Protect the root secret, not the derived keys. If you focus entirely on that single master seed phrase, you will drastically simplify your life. You don't have to stress about backing up a new file every single time you make a transaction. You just have this one vital, irreplaceable secret that you need to hide.
But how do we hide it? Well, when you compare the standard methods, a hard reality sets in pretty quickly. There is no magic bullet here. You are always balancing durability, secrecy, and operational complexity. Take a simple paper copy stored in a home safe. The operational complexity is beautifully low. Literally anyone can write on a piece of paper. But the durability? Pretty low if your house floods. What about an engraved metal plate sitting in a bank vault? Well, that gives you extremely high durability and secrecy, but it comes with higher procurement costs and effort. And then there's a Shamir split, where you mathematically break the phrase into pieces and stash them in different cities. Incredible redundancy, unmatched secrecy, but the operational complexity is just through the roof. You have to reconstruct it perfectly to access your funds. So as you can see, no single method gives you a perfect score across the board.
Which perfectly cues up Section 4, Building Your Disaster Plan Blueprint for Recovery.
Okay, time to shift from theory to action. Let's look at exactly how you are going to construct this artifact for your capstone project. The absolute crucial point here is operationalizing this mental model into a reliable, repeatable workflow. It's a simple three-step process. Step 1. Define your acceptable risk. What are you actually protecting against? A house fire, a targeted theft, or just accidentally dropping your hardware wallet in a lake? Step 2. Choose your backup media based directly on that specific threat model. And Step 3. Establish physical redundancy and segregation. Never, ever keep all of your copies in the exact same physical location. I mean, if the house burns down, you lose your primary device and your backup simultaneously. Game over.
The real secret to a robust, sleep-well-at-night plan is pairing complementary methods. Because no single method is perfect, you stack them. A fantastic strategy is combining an engraved metal backup that you store safely away in a bank deposit box, which completely handles your high durability and high secrecy needs, and pairing that with a simple paper copy hidden in a fireproof safe at home for convenient temporary recovery access. You're effectively using the strength of one method to offset the weakness of the other. It's a brilliant balancing act.
Now I need you to listen closer to this part, because this is your essential survival checklist for when you actually sit down at your desk to do this. Stress makes us make mistakes, so you need to follow this strictly. First, visually verify your device is completely offline. Second, write the mnemonic down slowly. Read it aloud to yourself, cross-check every single letter. Third, and please hear me loud and clear on this, absolutely, positively no photographs. Our modern instinct is to just snap a quick picture with our smartphones. Do not do it. That photo uploads to your cloud storage immediately and boom, your secret is completely compromised. Fourth, confirm a test restore on a test device. And fifth, physically store those copies in distinct, completely separate places.
Finally, we reach Section 5, Rehearsal and Next Steps, Proving the Blueprint.
Look, a disaster plan is completely useless if you've never actually tested it, right? It's just a theory until it survives a simulated disaster. So what does a successful rehearsal actually look like? Well, you have to physically transcribe your backup exactly, character for character, into a fresh test device. Then, you verify that the mnemonic actually restores the expected first-arrived address. If it suddenly generates a totally unfamiliar address, guess what? You wrote a word down wrong. You also want to track your recovery time. Does executing this plan take you 10 minutes, or is it going to take you 10 days of running around town? And lastly, if you did choose to use a passphrase, rehearse the restore process both with and without it. You want to intimately understand exactly how those mechanics behave when you're under pressure.
And that brings us to your specific mission. Remember, in our Forge College programs, we don't just talk about these concepts abstractly, we actually build them. For the upcoming guided wallet creation lesson, you need to bring this exact documented artifact with you. Write down your chosen mnemonic length, the media choices you made, your designated storage locations, and your rehearsal checklist. We are going to be executing that plan directly.
So I want to leave you with one final, slightly provocative thought to chew on. If your house flooded tomorrow, would your crypto survive? Having a bulletproof, offline disaster recovery plan is literally the absolute bedrock of self-custody. It removes the anxiety and replaces it with solid engineering. Take the time to build your plan today. Now, if you found this explainer helpful and you want to dive deeper into this subject, or really explore any other cutting-edge Web3 topics, I highly encourage you to head over to forge.college to access all of our educational resources. Thanks so much for learning with us today, and we'll see you in the next explainer.